Welcome to week 3 in GIS 200, and as you're watching and listening to this, you have been made aware that today is in fact a snow day. Unlike most places, they canceled the classes for this evening before it ever snowed, which for me is kind of odd, but seems like it's a pretty good idea, being that it has already started to snow here. It's about 3 o'clock when I'm putting this little video together, but it was snowing here well before 2 when they had set to shut down the school. And all of that was to prevent people from driving unnecessarily to class during rush hour. So what we typically do during a snow day is I will give the same lecture that I would give in class. The only difference is I'm sitting in my desk at home, looking at my laptop, wearing a headset. I haven't combed my hair, brushed my teeth, or done any of those things that make us more human. Instead, I'm sitting here lecturing about as comfortably as I can on what will be Chapter 2 from the Mary Beth Price textbook. And we'll go over, take a quick look at the syllabus and see what's due this week and what we're going to accomplish. And then I'll do the lecture, and then I'll post any other materials or things like that that you need to be aware of, or that you need to look at, or that you need to do in this week's folder. And everything should be up by, I would say probably 5 or 6 o'clock this evening. The slides will be up earlier, and they will be narrated, and you can of course always play those. But I do tend to convert all of the slide lectures like this that I narrate into a YouTube video that's on my YouTube channel, and I will post a link to that as well, and so you can always have access to that in the event that you're somewhere where you can't watch a PowerPoint presentation. Anyway, we'll get started now, and hopefully this will substitute for not being in class. So if you were to look at the syllabus and go to the weekly learning activities and assignments, you will see that here we are, and this is in the new updated syllabus, week 3, January 29th, lecturing on Chapter 2. Your assignments tonight after I lecture is to complete the teaching tutorials for Chapter 2. This is going to be your teaching tutorial assignment number 2. Exact same way that you did the ones in Chapter 1, but these obviously will be in Chapter 2. Answer the questions as you come to them in the textbook, and then when you're done, go and answer the questions on the teaching tutorial quiz that's going to be posted on in Blackboard. Now, don't get alarmed if you don't see the teaching tutorial quiz posted right away. I don't have my copy of the textbook with me at home, and so I can't verify that the questions are in fact correct, because last week, as many of you figured out, one of the questions did not line up with the answer sheet that the educational resource company McGraw-Hill has provided for the particular text. So I was basing my true-false questions and the answers that you should get off of the answer key that they give me, only to find out that they changed the question in the book but did not update the answer key. So I wanted to make sure I check that before I post the teaching tutorial quiz. But as you see in big bold letters, Exam 1, take home open not exam. Of course, obviously that's a typo. It's an open note exam, and basically you will have from class tonight until class next week to complete this. This exam will be exactly like every exam that you're going to have this semester. Now, what do I mean by exactly like every exam? I mean format, style-wise, types of questions, degree of difficulty, all those sorts of things stylistically will be the same from exam to exam to exam. Some exams may have more of one particular type of question than the others, but all in all, this exam will be very representative of what the other exams will be like. This should give you an idea of the level of detail you need to study and how much you need to prepare moving forward. And since this is a very introductory chapter, it's important that you learn these things. So an open note exam is a really good way to do that, because you have the questions, and if you know what they are, that's great. You can answer them. But if you don't, you have the ability to go back through your notes or the slides or your textbook and find answers. And that is one way that we can make sure we all get off on a good foot and we all get started in our GIS path, if you will, with a good heading and a strong foundation. So what are we going to be talking about specifically? Chapter 2 is about managing GIS data. And so we'll look through what the concepts and what all this means. But in general, it's pretty straightforward. It's about dealing with data, and that's something that you've all been doing these last couple of weeks, and you can see that at times it can be quite a struggle. Chapter 2. So the first thing we want to point out is that GIS data, they're different. It's not like ordinary data, because it has multiple layers of information that you have to have for the data to remain functional. So there's just plain old information like this is Loudoun County for a particular parcel. But beyond that, there's also other information about the spatial shape of the polygon that outlines Loudoun County. There's other data, not just the name of the county, but attributes, demographics, the area, the size, all these things. And then of course there's the spatial stuff, the purely spatial stuff, the where is Loudoun County. Then there's the topology of how it interacts with other counties and other layers and other states and those sorts of things. And all of that is important. And all of that is what makes spatial data special. So how are they different? Sometimes they're very large. Sometimes multiple people use them, many sources, many file types, sometimes local. Sometimes the data that you're working with, like our data on Citrix, is served. Sometimes you download data from other servers. A lot of times they don't follow the latest file conventions. The formats can get complicated. An example here on the right, you see buildings.dbf.prj.sbn.sbx.shp.shp.xml.shx. These are all files associated with a shape file called buildings. All these are data you must have in order for the data in general for buildings to function. So how do we organize data? Use organized folders and be aware of where you're saving things. The default location is not a good place. Name files with descriptive names. Okay? And here's what we mean by that. At some point in time, you'll begin to use tools, and you'll use things like, for example, maybe a raster calculator. And the output of that might be something like raster calculation 1. What does that mean? That tells you absolutely nothing. Whereas if you give it a descriptive name like snail habitat, it makes sense. And then when you're looking for it, you can find it because you know you're looking for the layer on snail habitat. Or when you see it in a folder, you say, oh yeah, snail habitat, that's what I was looking for. Now, we also have a little script here in this little window. An address of C drive, users, Maribeth, documents, ArcGIS, default 1, geodatabase. This is like the standard format for a default geodatabase that the software will generate if you don't select one. That's why it's important when you open up map documents and you go to do new things to utilize that scratch or working or draft, default, whatever you want to call it, geodatabase that I put in your student folders. That's a great place to store this. Now, if you've installed the software at home, this using the default geodatabase is less problematic, but it's still not a good idea. So when you copy your student folder from the Citrix server using ArcCatalog in Citrix, and you then paste that in somewhere on your computer where you have the software at home, if you're one of the students who have chose to do that, then you want to make sure that you know where that is and utilize that default geodatabase that we created in that student folder. How to use folders? Well, generally speaking, here is what you want to do. Always store data on your C drive, not the desktop, and not in your user folder. You want to develop some sort of an organizational system, something that works for you. Stick to it. You want two sort of branches in your folders that you're working from: working folders and permanent data. Okay, and then put the downloads in a separate folder when assembling the data. So what does all that mean? Alright, if you download data from an external source, you should download it into a GIS downloads folder. When you're playing around and working on data, it should be in a working GIS data folder. When you're making something that's useful that you're going to save as part of a project or something permanent, it should be in a permanent GIS working folder. Now, here is an example of a C drive where it says GIS class, and in that folder Mary Beth has created a downloads, a data folder, and then she has other folders that are in here. I tend to not like to have too many folders like this, but I would have a downloads folder, a working folder, and a project folder that I would locate somewhere. And these can all be inside your student folder. Okay, they can all be inside the geodatabase in your student folder. Naming conventions. This becomes important. Never use spaces in folder names. Never, ever, ever. You only use letters, numbers, and underscores. And always start with a letter, don't start with numbers. Keep your folder names short, about 8 to 15 characters. Okay? Now, the note here is it's not a requirement, but it's a good practice. Why is it a good practice? Well, long descriptive character names on folders, in files, can lead to very long convoluted addresses and can complicate things and make it difficult. It also increases the likelihood of doing things like adding symbols that you can't have, and spaces that will cause problems. And so don't do these things. Keep it short, keep it descriptive. 8 to 15 characters. You don't need to spell out in sentence format what things are. You just need to name it such that you can figure out what it is by reading the name. And 8 to 15 characters, letters and numbers only, and underscore. You can use the underscore if you need a space, but do not put spaces or dashes like the 8 to 15. That dash, you would never use that in a GIS folder or file name. So Windows allows this, but GIS does not. So let's just avoid it. When you see those sorts of things, if you're really hardcore in GIS, it just makes your skin crawl, because you're like, that's going to create a problem somewhere down the road. Something's not going to work, and it's all going to be because of punctuation or spaces. File extensions are the next thing I'm going to talk about. These are these 3-letter codes that you see at the end of files, and basically what they're for is to tell you what kind of file it is. It designates a file type. So if you think in the broader sense, things like .doc for documents, or XLS for Excel spreadsheets, or TIFFs as TIF, or JPEGs as .jpg, these are all the ways that helps us figure out what a file is. Now the computer, you can change computer settings to make these things visible or not. It can be helpful when you're downloading and importing data sets so that you know what you're looking for, so that you find the things that you're after. Now, speaking of which, that takes us to the first topic here: finding data. How do you find data? Lots of data that's out there. ArcGIS Online has a great deal of data. Not all of it can be downloaded. State and federal government sites have tons of data. Biggest problem? They don't all operate off of the same sort of interface, and so there's a steep learning curve. Every state or federal agency that you go to get data from is different, and so figuring out how to do it is a learning process every time you change agencies or government entities. There's also things called GIS clearinghouses. These are pretty awesome. They're big depositories of spatial data, and if it's a good clearinghouse, they're organized so that you can go through and find the data that you need for the things that you're looking for. They're grouped together either by geographic regions or common interests or topics. And then the other big thing is a lot of times these clearinghouses, they store the metadata right there with it, and so you can not only download it without any difficulty when you're downloading the data that you're looking for, you can also open up the metadata and take a look and say, hey, is this what I really need? Sometimes you can examine the metadata and figure out that the data you're looking at is just not going to work. Universities and research organizations have quite a lot of data available as well. Now, having said all this, some of this data is really, really awesome, and some of it is absolutely worthless. Some of it is like the rabbit hole in Alice in Wonderland. You'll fall in, and before you know it, you're seeing teacups and talking to rabbits, but you're not actually getting anything done GIS-wise because it's a dead end or a false sort of narrative in terms of what the data is. And so you're reading one thing and you're thinking one thing, and then you click on it, and 45 minutes later you still haven't found the thing that it seemed was really going to be quickly and easily found by the name of what it was that you're clicking on. So be very cautious and proceed with much trepidation when looking for and finding data from various places. Now, this is one of the places that the author likes to go to, data.gov. I'm not the biggest fan in the world of this website. It allows you to search a lot of different agencies all at the same time and do it. And I'm sure they've been improving it. Honestly, it's been a couple of years since I tried to use it very often. And the last time that I made a really concerted effort to get through and find stuff, it just didn't work really well for me. Now, I would imagine it's been improved and maybe it works better for you. So, this is a good place to learn, do the exercises and things like that that the textbook is requiring of you. And when the time comes to start looking for data on your own for other projects, don't forget about good old go.data.gov. So when you start searching for data, how do you do it? Well, there's a couple of ways. We're going to cover some of the basic ones that you can do. You can put in the topic of the thing you're looking for, like, for example, poverty information. So you can put in poverty in GIS and put it in your favorite search engine. Excuse me, search engine, Google or maybe Bing or whatever. You can put in the topic and then add the word shapefile if you're looking for polygons, or EEO, which is another old file format. You can look at the name of the place, so place names like Franklin or Tennessee or Loudoun County or Leesburg or Hardscrabble, along with terms like GIS or shapefile or EOO. EOO is an old file that a lot of times you see associated with like raster data, I believe. And shapefiles, of course, like I said, was polygons, and GIS is just a generic term for spatial data. So here are some examples. I hate that they use soils because there's a lot of soils data that's really easy to get to, and we're going to spend a little bit of time at some point, maybe in class, looking at this. This second link here, Web Soil Survey, is an awesome setup that the NRCS has that allows you to go in, put in an address, find a location, look at the aerial photos of the location, zoom in and draw a box around the place that you're interested in, and then it gives you all the data that they have for that area that you can then download. And so it's a really cool setup. But that's one example of how you could do it. Here are some other clearinghouse sites: the National Map, go.data.gov, the CDC, data.geocom.com. When you find a good site, make notes about how the download interface works, what data is available, how difficult it was finding metadata, the type of data that you found easily, that sort of stuff. It could come in handy later on. It's something you can also share with your classmates and perhaps even your instructor. Again, challenges, every site's different. Data comes in tons of different formats. Not all sites work as advertised. There's one institution in Virginia I'm not going to name that has a GIS data depository that I've only been able to download 1 or 2 files from ever. Not all the data downloads are valuable. You get a lot of junk out there. You need to develop a lot of general computer savvy when you're working with this, because you have different file formats, you have different download interfaces. Things come in, sometimes they're zipped, sometimes they're not. A lot of things you got to deal with. If you're not willing to try and fail and explore and search and learn and invent ways of looking for, finding, downloading, and accessing data from the web and other places, you're never going to be successful in this field. The data is generally there. It's not always easy to find. If you're not willing to look, you're never going to find it. If you stop the first moment you find something that sounds like it's right and say, "I've got it, eureka," you're going to fail miserably. It's never, almost never, ever the first thing that you find that's actually what you need. Finding data isn't just finding something you can download and say, "Look, I found data." Finding data is finding data that actually meets your needs. That means you have to find it, download it, extract it sometimes, or unpack it or unzip it, load that data into an ArcGIS or some other GIS type program, and explore it and see if it actually is what you need. Because more often than not, with young, new, freshly starting GIS people, what you find is not what you're looking for on the first try. Zipping, if they're zipped, you need to unzip them before you can use them in ArcGIS. 7-Zip is a free program that the author recommends. Source and scale is something else we want to talk about. And it's about finding a scale that's suitable for your project. And here we have a map on the right. Excuse me. I'm getting sleepy. There are multiple maps of the same location. The purple, the orange, and the black lines all map the same thing at different scales. And so at 1 to 25 million, 1 to 5 million, and 1 to 50,000, you get a very different detail level in terms of what you're seeing. And that's the point with understanding the source scale. You may think you have what you need. You might say, "Oh, great, I found what I'm looking for. This data, it's perfect." And then if you look at it just a little bit closer and you realize it's 1 to 25 million scale, it is so coarse. Will it really work for anything that you're trying to do? Maybe, maybe not. If you don't understand your data, you don't look at your data, you don't read the metadata, you don't load it up and see what it actually looks like, how do you make these decisions? The answer is you'll make them very poorly if you don't do these things. And a lot of times, frankly, they'll be wrong. So when we look at these available scales, small scale data, world, country, state are relatively easy to find over large areas. Large scale base data down to 1 to 24,000 is really common in the US. Very large scale data parcels are difficult to find, and usually they're very localized because there's no like concerted effort globally or even nationally a lot of times to put this together. And so when you're looking at individual parcels of who owns what land, for example, you're only usually going to find that within some local entity. And if you need it across a larger area, you're going to have to find it from each of the entities that make up the area that you're looking at. Now there's also specialized data. Geology is an example. These are typically only at small scales or at localized special areas as well. I have mentioned metadata before, but you may not know what metadata is. So I want to talk a little bit about it. Metadata contains information about data needed to understand the data and evaluate its quality. That's a very straightforward and very simple, but very crucially important thing to pay attention to. It is information about your data that you need in order to understand the data and make some sort of evaluation about its quality. Now, in theory, metadata should be provided with every set of data that is distributed to the public. A lot of times it's not directly stored with it, sometimes it's separate, sometimes it's its own individual download. That makes it problematic. Without metadata, it's really hard to assess whether data is of quality or not. Because if you don't know anything about it, how can you understand it and evaluate it? So it's useful for assessing the quality of data. And so this is sort of the generic way of sort of backing into what defines data quality. Quality data is data that has a fitness for a given purpose. Okay, if your data is of quality, it means that it is suited for an intended purpose. In other words, it's fit for what you're trying to do. If your data is of inadequate quality, it means it's not well suited, or it doesn't fit for a particular purpose. There's a couple different metadata styles. Generally, there's just item descriptions where you have this brief set of attributes. They're quick to create. It's the default style. There's excuse me. There's also standards-based metadata. This is more extended information, and you have to set the metadata style to see it if you want. So there's these standard bases that you see here to the right, the ArcGIS metadata and the FGDC metadata, and basically what it means is the general stuff is posted above in the item description. If you want more detailed things, each of these standards-based one provides more information relative to the individual standard. You can set the metadata style in the Customize app on your ArcMap options, and you can use FGDC or North American Profile, and that's typically what you would use for most US data. Document downloads. Update the metadata if you have changed the data set. This is important. What does that mean? It means if you download some data and you start changing elements to that data set to make it effectively something other than what you downloaded, then you need to update the metadata to reflect the changes that you imposed upon the data set. Now, Mary Beth, the author, she likes to put a source citation in the metadata credits so she knows where it came from. Basically what this means is if she takes a data set and she modifies it in some fashion, she'll create new metadata for that, and then she'll, in the credits section, put a citation about where the original data that she modified came from. Alright, so let's look at ArcGIS and specifically at what we can do to manage our GIS data. Map documents and data frames is the first thing we're going to look at. The map document itself stores collections of data for viewing and analysis, and sometimes you can have multiple data frames. And then for each one you can store properties for each layer, like the symbols and that sort of stuff. And it stores a page layout for printing, which is sort of the map view of how it looks when it's done. And it has references for all the files, not necessarily the data. It simply knows where the data is so that it can access it to make the maps. Now, GIS data are often shared. And here's an example. And this is the difference between, that we're going to talk here about the difference between a feature and a layer file. Here we have a feature class of counties for Oregon, and we have Tucker and Jenny and Eileen. And they've each made maps of Oregon for one thing or another. And from the exact same data set, you get three very different looking maps. Now, how is that possible? Well, map documents and data files are sort of separate things. Here we have a map that relates back to the data, and and then the data is displayed in accordance with some instructions to generate the look that it has. If you wonder where the data came from, simply go into your table of contents and select the data layer and look at the layer properties, and you'll see things like source, general, selection, display, symbology, etc. Under source, it gives you some general information. The extent, how far north, south, east, and west the data goes. It tells you the data type, in this case it's a feature class, where it's located, and that is the hard address of where the data is, in this case C drive, GIS class, MIS data, USA data, etc. Map document. It tells you what it is. It's a feature class called volcanoes. What feature type is it? Simple. What geometry? Points. It gives you projection information and all kinds of stuff that you can see from this. The key thing here is that in the source tab you can find the location, and basically it stores a path name, and this is going to be important. Path names are sort of the address of where the data physically exists. Now they come in two flavors. They come in absolute and relative. The absolute path always starts at the top of the data tree. And so the example on the left is a data tree. C drive. Inside the C drive you find the MGIS data folder. Inside the MGIS data folder you find the USA folder or the map documents folder and all the things that are associated there. If you look at the highways shapefile, that's hwys.shp, the address for that would be C:\\\MGISDATA /USA/hwys.shp. Okay? Now, the other pathway is called relative pathways. It starts at the location of the map document. If your map document is in the MGIS data folder, it basically starts at MGIS, or if better yet, your map document is in the map document folder, it starts there. Now, here's where it gets complicated. Say you copy your map and you put it on a thumb drive and you bring it in and you load up ArcGIS on Citrix at the computer lab, and then you copy over your map from your thumb drive and you want to show me something that you made, and all of a sudden there's nothing on your map except these little red exclamation points next to all your data sets. I call those the red exclamation points of death. It means that the pathway to your data has died, and the roots, or as the agronomists in the Midwest would call it, the roots of your growing data document have been severed. Well, if you have an absolute pathway, the moment you move anything, they're all going to be severed. Now, if you use relative pathways, as long as your data is in the same folder as your map document, it'll find it, as long as you move all of it together. Okay? You say, well, what if I move it all together? Will the absolute not work if it's still together? No. Because the moment you change computers, or you change C drives, or maybe it's not in the MGIS data folder anymore, the moment you alter anything on that absolute pathway, it becomes null and void and becomes a broken data link. Now in time you can get pretty good at fixing these by simply looking at where it was supposed to be, knowing where it is, and then updating the address. And it's not that complicated to do. And if by chance sometime in class you end up with one of those red exclamation points, flag me down and I'll come by and show you how you go about correcting that. But the easiest thing to do is to avoid it by using relative pathways. That'll take care of 90% of the problem. Again, they occur when you can't find, when a map document can't find data using the pathway. Here on the right you see the red exclamation points of death I was talking about. If it's moved or deleted, or the drive's not available, it's copied somehow incorrectly, all these things happen. How do you fix it? Again, go into the data source, set the data source, use that to fix broken links. When should you use these? Now, we're going to go through all 5 of these bulleted points, but I'm going to tell you that in general, my opinion is almost never is the correct answer for when you use absolute pathways, and just about all the time is the correct answer for relative. Absolute pathways are for when data is placed on central servers for many people to use it. The data will not be moved or rearranged, and you want to be able to transfer map documents without transferring the data. Relative path is when you plan to keep data with the map and move them together as a set. So here are some examples that are complicated and difficult to read and understand, and I'm not going to bother with them. File locks. File locks are wicked complicated because a lot of times you don't realize they're occurring, and once they are, nothing works and you can't figure out why, and you go into panic mode and you come get me, and I go into panic mode because I can't figure it out, and I don't want to look stupid and you don't want me to look stupid, and we're trying to figure out what's going on. Only we find out later on that you've got 5 different copies of the same map open, and that's why you can't modify the data in any of them because there's a file lock. Now, not just ArcGIS, but other programs can create these as well. And basically what happens is if 2 pieces of software are accessing the same piece of data, you can't modify the data in the ArcGIS program. It will not allow you to do that if another program is accessing that data. And so basically it locks it down and says we can view it, but we can't modify it. To remove it, close down whatever else is using it. Now, sometimes you do that and it still appears locked and it won't do it. And then you got a couple of options. You can save your map and reopen it, and sometimes that gets rid of it. You can remove the data set and add it back in, and sometimes that'll do it. Worst case scenario, you have to reboot your computer. Log off and log back on to your PC or laptop, what have you, and then open everything back up again. And usually by then it will be unlocked. Talk a little bit now about using ArcCatalog. ArcCatalog is our friend, but he's not a real good friend. Catalog interface looks an awful lot like ArcMap. That's sort of the first problem. Now, we're not talking about the ArcCatalog window that you can open up in ArcMap. We're talking about a separate standalone program called ArcCatalog. It does the same thing, but you have a few more options. And there's a couple components under the catalog tree. Basically, it's this nested design folder setup where you can find where all the data is on a given computer. Then you have a display window, which when you select something in the catalog tree, it shows you a display of the contents, and you can also look at a preview or a description of the data as well. And it also has various menus and toolbars. When you need to connect to a folder, in other words, the data that you need is not showing up in your catalog tree, use the little folder with the black plus symbol, and that allows you to then connect to the folder, and you basically just start out in the computer where it's at and navigate your way to the folder. Now, don't go navigating through to collect or select data. That's not what this is for. This is to create a connection to a folder. So if you have data in the MGIS data that you want to use and you want to look at it in catalog, you need to connect to the folder where the data is at. You don't connect to some shapefile inside the Austin or the Black Hills or Austin and Black Hills. You select the MGIS data folder, and then that will show up in your catalog tree, which you can then open up, expand, and work your way through. 3 different views: contents, preview, and descriptions are pretty much self-explanatory. When you're in contents, you can look at it in different ways because you have different viewing modes. One shows you large icons, one shows you the list, one shows you the details, and one shows you thumbnails of what the data is. The description tab can be used to view the metadata. You can also, users can create, edit, and import or export metadata from here. You can go to the Geography tab to preview that. Basically it gives you the sort of the map of the area, and you can zoom in and out and do all various different things with that as well. And you can look at the table view, which what this does is this opens up the attribute table that is associated with your particular feature class that you're looking at or shapefile. You can right click on the file name and go to properties and open up the feature class properties, and this will show you a lot of things. The most common thing we look at from here is the XY coordinate system, and so we can make some decisions about what sort of coordinate system it's using, that kind of thing. The other component, the catalog window, this provides access to ARC catalog functions within ArcMap. And this is really good because it keeps you from doing and having a lot of file lock issues. It looks an awful lot like about half of the ARC catalog program. It does a lot of the same things, just not quite as complete as the full catalog program. Some examples from it: you can go and create new things like feature datasets, that sort of stuff. And the catalog window typically comes up on the opposite side of the table of contents, but again, it has a very similar look to it, and please don't mistake one for the other. And you simply right click on things in the catalog window to manage them. You can look at item descriptions and metadata and all kinds of things from there. Now, time for a great big warning. ARC catalog and catalog window make permanent changes to stored files. Most of the programs like ArcGIS access the data and they do stuff, but they don't really change the permanent data file. Catalog and catalog window do. Okay? And they don't have an undo button. So be careful when you're working in any of these catalog entries. Now you might say, well, what am I don't understand, but how do I be careful? Well, earlier, several slides ago, we were talking about how you can set up file structures. One reason that you want to save your downloaded data and not work in it directly, but save it, copy it into some working folder, and then when you've finished doing what you need to do, save that into a final folder. It's because if you go into catalog and you jack something up, you can always go back to the working folder and get what's the last one you worked with, or go back to the original download folder and start over. If you don't have these things and data becomes corrupted, it's just lost, and that means you start over. Table contents, catalog window, know the difference, don't confuse them. How do you put data together for a geodatabase? Most items can be created by right-clicking the appropriate container and choosing the item that you want to make. Type in the name while it's selected and press enter. Really hard. You got a folder, right-click on it. I want to create a file geodatabase. Boom. You have a file geodatabase and you want to create a feature class. Boom. Pretty straightforward. So, how do we assemble a good geodatabase? The first thing you need to do is decide on a coordinate system, and then find all the data that you need, and then import all the okay. Let me try talking again, slower and clearer, so you'll understand. So, to make a good geodatabase, you have to figure out in your head the coordinate system that you need or want to use for this data, and then find all the individual data sets that you need. Now once you have everything that you need to bring them into the geodatabase format. And sometimes that means you have to do other things. You have to make subsets or query data or clip it or whatever. You may have to project it to a different coordinate system. There's lots of things that can happen. You may need to update the metadata. Any number of things. All these are a part of bringing in these separate entities of data into a single new cohesive geodatabase in a singular coordinate system. Import and export, there's lots of tools. Basically, it's the same operation, just depends if it's going in or coming out. Import, you can do that with coverages, shapefiles, rasters, and feature classes. Some like EOOs and CADs, you're going to have to go through a conversion process before you can import them or export them. How do you export data from ARC Catalog? Okay, select the data and click export. Basically, yeah, that's that simple. Or you're going to export it to a geodatabase, something like that's pretty straightforward. There's also tools like if you want to go from feature class to feature class. Lots of different ways that you can do this. Using ARC Toolbox, you can open the tools. Again, they're in conversion tools from one thing to another. It's sort of how they're laid out. You want to convert it into a geodatabase, so it's feature class to feature class, no problem. You want to use a query to export data. Open up a data set, put in some SQL function, it gives you a subset, and then that subset becomes highlighted. And then if you do the feature to feature or the export or the import or whatever you're doing, it only applies that to the data that's selected. This is an important and key thing to remember. Anytime you're doing anything with data, if you're going to copy it and make a new one or apply some tool or function to it, if you have a subset of the data selected, in other words, not all the data is selected, it will only do the things that you're asking it to do to the data that is selected. So, good practices. If you don't want to work on a subset of the data and you want to have all the data that you have, make sure you clear selected features before you do any sort of anything. If you want to create a subset of data that only reflects part of the data set, select the data set that you want the procedure or the entity or whatever to reflect, then do the thing that you're trying to do, and it will only do it to the stuff that you had selected. Now, good rule of thumb, once you do these things, clear selected features so that you don't mistakenly do this again. Clip tool is another cool tool. It's in the analysis tools. It's a means of extracting data, and basically you have one data set and another data set, and it basically works like a cookie cutter where it just chunks out part of one data set based on the shape or the confines of another. When you use things like that in these various tools, at the bottom of a lot of these tools there's an environments tab. And what you can do is go in the environments tab and change the output coordinate system. So instead of manually going through and changing the coordinate systems on all these individual data sets, if you use a tool to convert it from one place to another or one thing to another, you can at the same time change the coordinate system by simply setting up the environments so that when it goes to the output of the function, it will go ahead and make that change as well. Exporting an ARC map, here's the most basic scenario. You've done some sort of query. You've selected, in this case, 21 out of 3,141 polygons, and you can see where they're selected there. Export the data, select your coordinate system. In this case, you want it to match the data frame, and it'll do that. Now, you could have said to match the source layer, in which it wouldn't have changed it. Now, if your data frame has a different layer, this would fix it. How do you set these? Well, the data frame and the output coordinate system are chosen for the new geodatabases. A lot of times we just pick basic things like NAD83. When you have a new blank map and you add data, the very first data piece that you put in will be what the coordinate system of the map. I don't think I made that very clear, so let me just try that again. I've opened up a new ArcMap document. It's completely blank. It has no coordinate system. It has nothing. I add in a data set. Okay, whatever that data set is that I add in first, whatever its coordinate system, be it geographic or projected, becomes the coordinate system of that map document, for good or for bad. Here in this example, um, we have the U.S. that ended up in the New Jersey State Plane Coordinate System, and you can see it does not look like the U.S. It's really skewed out west, which is a long way from New Jersey. Query the table to select subset of features, and so we select those counties. We talked about that. And then once you have them selected, you can go down to export it, and you can select the data frame, and it'll just keep whatever the data frame is. Of course, you can set that as well. Arc Toolbox, how do you use it? Tools are organized, hundreds of functions are organized into tool sets, and you can expand these by purchasing extensions. As students here at Nova, you have access to all the extensions. Everything that you can run in ArcMap or ArcCatalog, we have access to. Now, you can pull tools out of different tool sets and put them together and create your own custom ones if you want. Sometimes that makes it easier to find them. Basically, once you find one, double click on it, the tool opens. Once it does, it gives you a little graphic user interface where you select features and options. When things are not correct, it gives you warnings and errors, and usually you can work your way through and figure out if that's something significant or not. When all else fails, pay attention to the tool help. If you don't see, when you open up a tool, a window like the one here on this slide, where you have this window off to the right explaining stuff, and the window off to the left where you put in and select things, your help is hidden. And so right next to the Environments tab, there's a little thing that says Hide Help. If you were to click that, everything sort of from the right of that up and down line, just to the right of the Hide Help tool, would vanish. And it wouldn't give you any suggestions. Now, if you click Show Help and it pops that open, the unique thing that happens is if you were to, example, select that box up at the top that says Input Features, where you select what it is you're trying to do the particular function on, the moment you click on that option or that field, the box on the right is going to be populated with information about it in terms of what it is or what you're trying to do or what you can do. How do you find tools? Mary Beth teaches you guys to do things like use the search function and put in words like dissolve, and you'll get all these dissolve tools. I hate that. What I would really like for you to do is to nose your way through the entire catalog tree looking for things, because tools are grouped together based on what they do or how they work or what they work with. And so you might be looking for a particular tool but not know where it's at and not be sure of the name, and so you type in something similar and eventually you find it, you think, and then you do it and you run it. Okay, if you look for it the other way, as you get into the folders where these tools are at, you might come to realize that in fact there are 6 or 7 tools that do very similar functions to what it is you're looking at or looking to do. And maybe the one you thought you needed wasn't the one you needed after all, and that there's another better tool for the job. Now, does that mean I want everybody to stop searching? No. What it means is I want you to spend some time looking through Arc Toolbox to figure out how the tools are nested with similar tools that solve similar problems, because it's not always going to be as simple as I need to dissolve something, so I'll put in dissolve. What happens when the thing that you're trying to do or the function you're trying to apply or configure is something much more convoluted or complicated? A simple search like that may not find it. So do what Mary Beth says and learn how to search for tools that way, but also don't be afraid to go to the Arc catalog or the Arc toolbox and just start opening up tools until you get inside to see the individual tools, and then if it looks like it's something that could be helpful, when you get a chance, look at it and see, maybe somewhere down the road you'll use it. Background processing lets you keep working while a tool runs, but it slows things down, makes it confusion, and everything crashes. This is a stupid thing to add to the software, um, so we want to turn it off. How do you do it? Geoprocessing options, background processing. Make sure that little box that says enable is not checked. Alright, Esri user data and maps. There's a DVD and some downloads that you can get that comes with the software. Many of you often don't download it or forget to download it, and that's okay. If you need it, we can always get it for you later. It comes with some restrictions. These individual layers are really useful, but there are limits to how it can be redistributed. So we got to use it for class. You can't use it for private industries or private interests or that sort of stuff. You can't make a copy of it and give it to your brother-in-law or your cousin Tommy or your Aunt Sue or that girl Barbara that was in your other class that's doing that thing with maps that said she was having trouble with this, that's supposed to know just some GIS, but you're going to give her the data. No. You can only use this stuff for related to class-related projects, school-related things, and you can't copy it and share it with other people. Don't do it. Well, that's the end of the slides, and I just wanted to take a couple minutes here real quick to do a sort of a general thing. I will post the upload links for the tutorials later, probably tomorrow, assuming that we don't get enough snow to close the college tomorrow. I want you to obviously listen to this lecture and then work your way and try to get through the tutorials. Follow the instructions. If you get stuck, watch a video. Now, your exam, open note, open slides, open whatever, 100 points. That link will be posted later this evening before class time. You have until beginning of class next week to finish it. It's 100 points. I wanted to remind everyone that I do make myself readily available to help. Tomorrow, assuming we have class, there is a training that I'm going to probably go to at 3 o'clock. It's in the HEC building, but it's not near the lab. Now, if you catch me before 3 o'clock when the training starts and you want in the lab, I'd be happy to let you in. If you email me and say I'm going to be there at 3:05 at 3 o'clock, I'll probably go on to the meeting because I probably won't get the mail in time. If you're going to be a little bit late, I'm more than willing to be a little bit late to my training to stay and let you in by a few, like 5 or 6 minutes. If you're going to be a half an hour late, you're going to have to try to convince the campus police to unlock the lab for you. They can always come up if they don't want to do it. They can come up and verify for me that it's okay. I'll be in, I believe it's HEC 215 is where the training's at. Now the training should be over by about 5 or 5:30, I think. So anytime after that training's over, so we'll say between 5 and 7, I will be in the lab, and so if there's something you need help with, something you want to talk about relative to the class, the software, or what have you, stop in and see me. Any other day, Tuesdays, Wednesdays, Thursdays, I'm basically around either the office or the lab from about 3 to about 6, which usually turns into about 7. If you send me an email, and I know to expect you, that's a big help for me. If you're in the neighborhood and you just want to stop by, don't not stop because you haven't sent me an email. Just go ahead and stop. The default is just go ahead and stop, okay? And I'll do my best to try to help you through whatever it is problem-wise with the software with the text, with the homework, whatever the assignment is that you need to improve your understanding on. That's what I'm here for. So, again, work through your tutorials. That's going to take you a couple hours. Watch this video. That's an hour. Take your exam. That's some time as well. Next week, by the time you come to class and you've done all these things, you're going to start to have a much better appreciation for how to, in a more timely fashion, follow Mary Beth's instructions as you do the tutorials. And next week, we're going to do not just the tutorials, but we're going to start doing some exercises as well. Now, if because of this blasted storm, we get hung up a little bit, we may spend a little time next week in class going over parts of the tutorials for Chapter 2. Okay? Only if we need to. And here's the big thing. I'm not going to do them all. I'm not going to go step by step through the whole thing like we did for Chapter 1. But I can work some time in there if we need to for that. But Chapter 3 is a really long chapter, but I'm going to cover it over 2 weeks, and so we have a little bit of time there should we need it. Okay, you know what you got to do. I'm going to make an exam next and post it. I'm going to post these lecture slides with the narrations on them for you. And at some point in time there'll be a link, so a video link, and you say, well, if you got the slides, want the video, you can watch the video on your phone, okay, while you're sitting at the dentist's office waiting for an appointment. You don't have to be at a computer to learn. So I try to make the videos when I can, but I always provide you the slides with the narrations at a minimum. Okay, so now you know what you got to do. Good luck. Have any problems, stop and see me. Send me an email. You can post a message, but that sometimes takes weeks before someone notices one's been posted, so I wouldn't recommend that. I would say email me or come see me. All right, we'll see you next week. Enjoy your snow evening.